So now in this episode, you will learn about inverse of an element and inverse of a function. Now suppose we have got two sets, set A and set B, which are related to each other by the function f, and the set A contains different elements x, so that x belong to set A, and the set B contains different elements y, y1, y2, y3, y4, and so on, which belong to set B. Now also remember, you have already studied that the elements y in the set B are called as image of the elements x in set A, or we write it as y is equal to f of x, where y is called as the image of element x in set A. And also the element y is associated to some element x in set A, and this element x is also called as pre-image of the element y, and this is what is also called as inverse element of y under the function f. So that means x is equal to f inverse y is called as inverse element of y under f. You also learned about different kind of functions like one-to-one, many-to-one, and on-to functions. So as per this function, you will find that some element in set B will be associated to only single elements in set A, or we can say some element in set B will have only one pre-image in set A. But you will also find that some element in set B will also have more than one pre-image in set A, and there are also some elements in set B which won't have any pre-image in set A. Now to make it more clear, let's find out the inverse element of each element in set P. Now f inverse y1 is equal to, as y1 is the image of x4, so f inverse y1 is equal to x4. Now f inverse y2 is equal to, y2 is the image of x5, so f inverse y2 is equal to x5. And now what's the inverse of element y3? You can see y3 is not associated to any element in set A. So that means it has got no pre-image in set A. So that means f inverse y3 is equal to an empty set or phi. And f inverse y4 is equal to, now y4 is associated to two elements in set A, which are x1 and x2. So f inverse y4 is equal to x1 and x2. Similarly, f inverse y5 is equal to x3. And again, y6 is not associated to any element in set A, so f inverse y6 is equal to phi. Now let's solve some questions on inverse of elements for a given function. And the first question is, if f is a function from Q to Q and is defined as f of x is equal to 2x square, then find the value of first f inverse 32, f inverse 50, and f inverse minus 10. Now we have find the value of x for which f has a value of 32. So let f inverse 32 is equal to x. Now f of x is equal to 2x square. So we can write 32 is equal to 2x square. Or that becomes x square is equal to 32 upon 2, or x square is equal to 16. Now if x square is equal to 16, then x is equal to plus minus 4. So f inverse 32 consists of two elements -4 and 4. Now let's find the value of f inverse 50. Now let f inverse 50 is equal to x, or we can write 50 is equal to 2x square, or x square is equal to 25. Now x square is equal to 25, then x is equal to square root of 25 or plus minus 5. So that means f inverse 50 is equal to the set of -5 and 5. And now we shall find the value of f inverse -10. Now let f inverse -10 is equal to x, or we can write -10 is equal to 2x square, or x square is equal to -5, or that means x is equal to plus minus square root of -5. But square root of -5 doesn't belong to rational numbers. So that means f inverse -10 has got no value, or f inverse -10 is equal to 5. Now let's solve one more question. If f is a function from R to R and is defined as f of x is equal to x square plus 3, then find the value of first f inverse 9, f inverse 28 and f inverse 12 and 39. So first let's find the value of f inverse 9. Now suppose f inverse 9 is equal to x, where x belongs to real numbers. So now we have to find the value of x for which f of x is equal to 9, or we can write f of x is equal to 9. Now f of x is equal to x square plus 3. So we can write x square plus 3 is equal to 9, or that becomes x square is equal to 9 minus 3 or 6. Now if x square is equal to 6, then x is equal to plus minus under root 6, which is also a real number. So that means f inverse 9 is equal to the set of minus under root 6 and under root 6. And now we shall find the value of f inverse 28. Now let f inverse 28 is equal to x, where x belongs to real numbers. So now we have to find the value of x for which f of x is equal to 28, or we can write x square plus 3 is equal to 28. So that becomes x square is equal to 28 minus 3, which is equal to 25. Now x square is equal to 25. That means x is equal to plus minus 5. So f inverse 28 is equal to set of -5 and 5. Now let's find the value of f inverse 12 and 39. Now suppose f inverse 12 39 is equal to x, where x belongs to R. So that means f of x is either equal to 12 or it is equal to 39. So we can write f of x is equal to 12 or f of x is equal to 39. And then that becomes x square plus 3 is equal to 12, or x square plus 3 is equal to 39. Now if x square plus 3 is equal to 12, we can write, in place of it we can write x square is equal to 9. Similarly, in place of x square plus 3 is equal to 39, we can write x square is equal to 36. Now solving both of them, we get x is equal to plus minus 3 and x is equal to plus minus 6. So F inverse 12 and 39 consist of 4 elements minus 3, plus 3, minus 6 and 6.